Okay, I guess we're ready to get started. I think most of you know who I am, but just for those that don't, I'm Thomas Erdman from Seiler Instrument, formerly from Wisconsin State Patrol, retired from the Technical Reconstruction Unit back in April 2019 is when I started with Seiler. Basically my role is training and tech support for forensic mapping. Seiler is a geospatial company, so they do sell to a lot of construction and building, but also been in the forensic market for many, many years. They are the authorized Trimble dealer in the Midwest in like seven states. So it was just a position that I really kind of fell in and just absolutely love. I'm loving my retirement job working for them. So what we did is we volunteered to, since I am a MATAI member, and I signed up for the training, we did volunteer to map the crash test to come up with some very usable data for you guys that you can take home and, you know, as you want to, if you want to analyze these a little more after the class, or we can analyze them in the class, but we got all the data. So I just kind of want to cover what we kind of did, what our process was in the forensic mapping, and what is the product that we're going to give to you guys. So here we are, this is what we have. We were all out there yesterday. This is the road, or the little road to the fire department that we mapped where our crash tests were, right in here, right near the water tower. And the first thing that we did is what we wanted to do is we wanted to map the roadway and scan the roadway before we crashed any vehicles. So then after the 6 crash tests that we did, we could just lay that data right over the top of all that mapping data that we already had. So what we did is we processed this in Pix4D. So we flew a drone, and what we flew is a little Mavic 2 Pro, looking like that. And it's got a 20 megapixel camera. Who here uses Pix4D? I think Missouri does. And what are you flying for a drone? Inspire 2. Inspire 2, okay. Very common. DJI is a very common drone. The Mavic 2 Pro, I think nationwide, is probably one of the most common that are being used for forensic mapping, just because it's very inexpensive, has a 20 megapixel camera, and will get you some good results. So there's several ways you can scale your Pix4D project. I mean, you can put a steel tape out there, have some known measurements out there and scale it. What we did is we mapped this with GNSS. Does anybody know the difference between GPS and GNSS? Missouri does. How do you guys map your GCPs? Do you have put GCPs? Pardon? We use the RTK system. RTK system, okay. So when we say GPS, what GPS is, and like, you know, you can get a position on your phone of where you are, approximately, not real accurate, but pretty accurate. But GPS, when we talk about surveying or mapping, it's communicating with satellites up in the air that are circling the Earth, and that's American satellites. So I have to have a minimum number of satellites to get a good position. I also dial into what we call the WISCORs, or the Wisconsin network, that's giving me corrections. It's also communicating with satellites. But if I don't have enough satellites in there, because I don't have the minimum number of satellites up there, I kind of have to wait to take a measurement. So how you get around that is GNSS, and GNSS is really talking to other constellations, in other words, other satellites from other countries. So we're communicating with satellites from the UK, so I don't have to wait for those corrections or to take those shots. So that's a little bit of the difference between the GNSS and GPS. So what we did is we mapped those with the Trimble R4. It's a GNSS system really marketed and developed for law enforcement. And what we did is we put these photogrammetry markers out that are 2 by 2. And we have a hole in the middle, so we put a PK nail in the middle of those. And we basically mapped the position of the center of 5 targets there. And when we do these, we want to make sure that we don't have them all in line. We want some good geometry here. So for processing in the Pix4D software, we get some really good results. So then what I do is we export this, and I actually bring it into our Trimble software, which is Trimble Reveal, and we'll export a calibration file, and then we'll bring that into Pix4D and then process it. So I'll show you the results here. So here's our point cloud from Pix4D. And if you look in here, you can see, I'll zoom in here, you can see the center of our targets. When you're out there doing the crash test, we left those out there. Probably remember seeing those out there. So those are the center of the targets here that we mapped with the R4. We brought that data into Pix4D. And how we fly this is we fly a grid pattern or a double grid pattern. And so how I flew this was a pattern, something like this. And then after the drone takes those pictures, I fly it like this. Now, just because there was no vehicles or evidence and it was pretty flat roadway, I could have probably just got by with a grid pattern, but I did a double grid pattern, kind of like if it was from a crash scene. So basically, if I put a box here, you know, on the software, I fly these autonomously. You can fly them manually too, but it's going to drop a photo at all these locations. And you typically, with Pix4D, you don't want a camera that's going to be zooming in. You want them pretty much straight down. I tilt the camera up about 10%, so it's like an 80-degree angle. Pix4D doesn't really like pictures with the horizon because it's really looking for common geometry to stitch stuff together. So we really want them ortho, straight down as best we can. If I have a vehicle here, a crash vehicle, if I fly a grid pattern with a little 10% angle, if I fly this way, I'm going to get a photo of a little bit the side of this vehicle. And as I fly back this way, I'll get a little bit of the side of this vehicle. Now, if I just do a grid pattern, I'm not really getting the side of this vehicle and this vehicle very well. So that's why I do a double grid, because then when I come back and forth, I get a little bit of side data on the vehicles. And then it's just a matter of importing, I think it was like 135 pictures with that R4 data into Pix4D to process this. What's nice about Pix4D is I've done things where you're not really legally can fly over moving traffic. You can certainly fly right on the side of it. And if you're up high enough, you'll get the roadway. Or you can play Frogger when there's breaks in traffic. You just can't be directly over moving traffic. That's the FAA rule. What's nice about it is if I fly this and there's a car that drives through here as I'm flying it, when I process it, you will not see that car in my point cloud. And really what happens is, you know, Pix4D is taking one photo and the other. It knows where it is kind of geospatially, but it's also looking for a lot of common geometry. And he says, yeah, this one's going to match up with this one really good, and I'm going to stitch these together. But this car seems to be in different places on both of these photos, so it must be moving, so I'm just going to throw it out there. So I got a really good example of like a Indiana trooper showed me one he did. He's like, I went out there, and I got some more data the next day with a drone, went out there and flew it all, busy interstate, and the only car that showed up on that roadway was my squad car that was parked there. Because Pix4D sees all that stuff that's moving and just disregards it. Now, if someone's standing there or moving real slow, you're going to get some shadows, kind of like ghosting in there. In Pix4D, you can take that stuff out before you process. So what I did is I just clipped this just to clean it up a little bit in a rectangle box. And then what we do, certainly you can take some measurements in here in Pix4D if that's all you have, if you're doing your recon and that's where you need to get your data. If you zoom in here, obviously we didn't do any crash tests prior to, but I mean, if you look in here, it might be a little hard on the screen, but you can see the tire marks in everything. So you really can find a lot of your data just from your Pix4D stuff. So, but how we do it is we export this. We export it in what we call a .las file. And then what we're going to do is we're going to bring in the GNSS data into our Trimble Reveal, and then we lay the Pix 4D on top of that. The next thing that we did before you guys came out is we took the X7 scanner. That's the one in the back of the room. You guys probably saw it out there. What's unique about that scanner is it is auto leveling, auto calibration, and auto register. So it's not bringing a whole bunch of scans into some software to register them. They register right at the field from one scan to the next scan, and colorizes it, and we can bring it in and view it in 3D right away. So what we did is we came through and we scanned this whole area before you guys got out there. Another thing we did is we took the crash test vehicle, we parked it down here, and then we did a 360-degree scan of just the vehicle. And then I took my Seiler truck and I put the scanner on the back of the bed to get kind of the top of the truck. So we're able to now section just that car out so we have a point cloud of just that vehicle. And then from there, once we did our crash test, we took the R4 and mapped the final rest and our evidence and tire marks for each 6 crash tests, and then ran the scanner around for each 6 crash tests. So Chris Lutz from Trimble did all that stuff, processed that, while I was processing the Pix 4D here, and he's going to present them what the results are on that.
Good to go?
Yep.
All right. So since I cheaped out and I only bought one lapel mic, I've got to switch out our mic here.
And our computers, I think.
And our computers. Outstanding. All right, and let's cross our fingers and hope we got something. Okay. I can get this up here without unplugging anything. Ever so gently. Outstanding. Jump around in front. Yep, sounds good. All right. All right, so Thomas went over the kind of the methodology we used and how we got to where we are now. And so my job in being here is I'm here as a representative for Trimble Forensics, and my job was just to assist Thomas in more or less the grunt work. He knows the stuff better than I do, but my job here was to just give him some relief and, again, divide and conquer and get the most out of the crash tests that you guys have. If I have a little bit of word salad, I apologize. I'm on about an hour and a half of sleep last night because I had a bunch of things to do. So again, if it is word salad, I apologize. Hopefully it'll all work out. Okay, so what I'm going to go over with all of you is all too often, and I've been a victim of it too, somebody comes in to do a demo or a software demo, especially with mapping stuff, and they set an instrument up and they run it around a car in a parking lot, and then, all right, that's how the instrument works. Now let's go inside, and here's this data set from 6 months ago that we've had 6 months to polish and really make it look nice, okay? And that doesn't really show us what the back end work is, what's involved in the back end, the details in what you have to do to get from field to finish. So what I'm going to do is I'm going to show you guys, I'm going to do some processing, but not much, just because some of these things take a half an hour to 45 minutes to just ingest. So I've done the ingestion process, but I'm going to show you guys just how this stuff works on the back end. Give you a full-blown field to finish. This is how we got here. Okay? All right, so some of you saw yesterday that we were using the Trimble X7 laser scanner with the perspective field software. Did any of you guys get a chance to run it, walk around with it, anything like that? Anybody go, oh, we know, yeah, she got a chance to run it. So the advantage of this is laser scanning is tough, especially when you set a scanner up and you don't know what you have until you get back to the office. And that's a horrible feeling when, oh no, I missed something, or I don't have enough overlap and it won't lock together. And now your scene's gone. You've released the house. You've driven 2 hours back to your post and the scene is gone. And that horrible feeling. I've had it happen to me. It's a horrible feeling. Just the pit of your stomach feeling when a family of 4 has been killed and we didn't get everything we needed. So the advantage with the X7 with the perspective software is you get to see what you're working in real time, and you're doing laser scan registration in real time at the scene. If you don't have enough overlap, no problem. You just go back and you set up again and get that to all click in. So what I'm going to show you is the Trimble RealWorks software. And for people streaming online, I am going to move over now to, hopefully that's being displayed. And yes, it is. All right. So this is Trimble RealWorks. And what you're seeing here, there was no registration. I did 0 registration on this last night. We laser scanned, as Thomas said, we went out before you guys got there just to get the entire roadway, get that part out of the way. The roadway typically doesn't change. I mean, it can, I guess. Usually with the CMV crashes, it usually changes considerably. But for our purposes, the scene didn't change while we were out there. And I did no registration here. This is how it came in. I'm a big fan of transparency. I'm a big fan of show it like it is. You can see here, we were standing in it at one point. I haven't done any cleanup on this. This is what it is. This came right out of the tablet, and I dumped it into RealWorks. It took me about, I suppose, about 10 minutes or so just to ingest, and that was it. There was no registration. There was no monkeying and fiddling around. This is what we got. And this was a total of, what do we have here? So some of these were about 43 million points, 46 million, 9 million. We really did a bunch of different laser scans here just to make sure that we got the roadway before everybody got out there. So once everybody got out there, I'm going to turn this off. And I'm going to turn on crash number 1. And this is what came out of our T10, uncleaned, unmessed with, unregistered. This is what we came out with. And that is just 2 laser scans on this. Yeah, you can see all the people running around. We've got, and we did 2 moves. They were pretty conservative. We didn't go very far. On crash number 2, here's what we have. Again, I didn't touch this. I didn't mess with it. I ingested it and I renamed. We've got our groups here, crash 1, crash 2, crash 3. I renamed the groups and that's it. That's all I had to do, just for simplicity's sake. Now, each one of these crashes, including up to crash, what was it, 5 here. I believe 5 was the bicycle that got caught underneath, or both of them got tangled up underneath. And again, this is what it looked like coming out of the X7 and out of perspective. This one is 5. We had a total of 22 out there just doing scene work, and then another 9 before everybody got out there. So this is, yeah, this is only 5.
How big are the files per scan?
So this entire project was, I think, 1.9 gig. And that was everything. Yep.
How long did each scan take?
The majority, so what we wanted to do is, the advantage for us coming out here before everybody got in is we didn't have to do, you know, more detailed scans and go down a long ways to fill everything in. These were set at 2 minutes. which actual time is closer to 2 minutes and 30 seconds. Your scan time is only 1.5 minutes. And it does a calibration check to make sure it's within our specs, our tolerances. If it's out of tolerance before every scan, it checks. If it's out of tolerance, you get a red light and it won't allow you to continue. And it does that calibration check before every scan it attempts. So your data is gonna be good, and that adds just 30 seconds on. So it's a pretty short time. You can go up, and again, these are 2 minute. You can go up to a 15-minute if you really want to get detailed with it. But all these are is just 5 2-minute scans, and we're out. To look at everything. Oh, yep, sorry.
I know we're just looking at the 3D point cloud data. I'm just curious to see what the scan explorer.
So the Scan Explorer, yeah, let's do that. So we have something called the Scan Explorer, and what it is just it's a program that you can distribute out to somebody. They can open up and view your scan data without having to install any software. So say on crash 3, and we'll move over here, and I didn't generate a key plan for it. If we wanted to see, I think crash 5 was the interesting one.
And I'm assuming from here you can still take measurements if you need to.
Absolutely. If we needed to know any dimension on here, we can definitely do that. And this is just quick throwing it out there. Good question on the Scan Explorer. As you can see, and this is a good thing here. Typically there's a key plan which shows you kind of a bird's eye view of where the stations were set. I didn't generate one. I didn't touch this. I didn't think we would go into it. Thank you for asking.
The reason I brought it up is I did have a scan that was actually on the did go for we actually used the Scan Explorer part of it in the trial. And that's usually the best. The 3D point cloud was a little bit we couldn't see very well. But once you saw the Scan Explorer, the entire series I
Yeah, it's a very, very easy to understand, very easy way to understand it. So with all of this, I wanted to show you guys, I'm going to turn everything on, and that includes every crash test we did. Here's where all the vehicles, all the people, this is the way it came in. If I turned everything on. But again, remember, we broke each crash down into a group. So and Tracy did an awesome job running it, so we didn't have it all in one great big jumbled up mess. I mean, typically we don't do this, run the same crash over the same area. But for this, it came out in different clusters of information. I dumped it in, and last night I think I only spent 15 minutes in RealWorks just pulling the vehicles out. Drew around them. Actually, I was going to do that for crash number 3, I believe. So for crash number 3, we have our vehicle down on the other end, and here's what I'm going to do. I'm just going to grab the vehicle out of here. So we have our vehicle, and we have number 3 here. I'm going to grab my vehicle, so I'm going to do a segmentation. Guess it would help if I turn the right one on, huh? And I've already pulled that one out of there. Okay. Well, just for grins and giggles, here's what we're going to do. We're going to grab somebody that's walking here. I'll just say they're part of the scene. So I'm going to grab that person, and I am just going to draw a quick box around them. Say I want to keep it. This down. And I create it. Now my person is my own object. At this point, I'm set to export it out to our diagramming and analysis software, which is Reveal. So from here, I just hit export selection, and I'm going to put this In our E57s, I'll just call this walking, and I'll export. And you can do this for as many objects as you want. At more complex scenes, I'll have dozens of point clouds that I'll just chop out and send it over to Reveal. From here, that's RealWorks. I'm done mucking around with point clouds. I don't particularly like obsessing over millions upon billions of points of data. I've got other stuff to do. I've got reports to write. I got stuff to do, and I don't want to obsess over this. I got to get going. So from there, we head over to our diagramming and analysis software, which is Reveal. As far as like a evidence log, it does not. So what's in there is in there. You can. Now you can duplicate that. Yeah, you can duplicate it if you want to. However, what I typically do when I dump things out into Reveal, or when I go scan a crash scene and I want to bring it into Reveal, I'll bring in one point cloud that is untouched. I haven't chopped it, I haven't done anything, I ingested, and I spit it out. From there, I'll go through and do my cleanup, and then I'll make it look pretty, and I'll ingest all of that into Reveal. Now, when the defense wants to say, what did you do to mess with this? Well, here you go. Here it is, raw, untouched. Here's all the firefighters walking through. Here's the fire truck parked right on top of my evidence. What you see is what you get. Now, here's what it looks like when I clean it up, when I take that fire truck out and represent the scene as it was in the moments after the crash. I flip the switch, and that's what I get. Good question, though. All right, from here, I have gone through, let's see if I can get this to close. Down there with you. It's wanting to do some funky stuff since I've got a live stream software also operating here. Cloud, come on, baby. All right. Murphy, man, always shows up. I've had Reveal running since about 4 o'clock this morning, so it's, she's on the struggle bus on this laptop. All right, I'm going to reopen my scene and we should be good to go. So on this, all I have done is I've just ingested data. I haven't really done anything more than that. It's going to take us a few minutes to get her open. And there we are. All right, so here's what I did, is I imported a, let me turn that off. So I imported my point cloud for the ground. That's it. So that's what we got out of it before you guys came out, and we had our ground. And since our ground wasn't going to change, well, we can reuse that. In addition to that, I imported our hold down vehicle just as a way to show where everything came from. A very nice, easy way to do it. I imported our bullet car. And that was the Trailblazer before we started mashing it up. And as Thomas said, this was the 4 or 5 scans around and one on top of his truck. That's what we have. Now this point cloud is its own object, and I can move this around as need be, just as an exemplar. And this is what it'll look like pre-crash. A lot of times I'll do this for a momentum problem, where at the tow yard, what I'll do is I'll laser scan both vehicles. I'll go into RealWorks and create a slice through them and put them together. I'll export them as their own point cloud, bring it into Reveal, and then line it up on the marks that it created. So that way I've got a perfect slice and perfect damage alignment, and that's really helped me just really narrowing down those impact angles. That's a feature we can do with it that doesn't take a whole lot of time to do. Once we had that, I began working on our tests. Now if I turn off our bullet car and I just work with test number 1, we'll see here we've got some points that we're measuring. Now Thomas talked about the R12, or I'm sorry, not R12, the R4 GNSS instrument from Trimble. He went out there, he didn't have to set up, didn't have to level anything. Using satellites, went out and plotted his points, and that was, in between every crash. And that included starting up a new job, hitting 2 points, or actually 3, mapping the data, closing it down, and he still had time in between each crash. So what he did is he plotted these points. Now that's another problem with, sometimes with laser scanning. Sometimes you can't see those really faint tire marks. The things that are really hard to see and all too often are the important part of the case. Sometimes laser scanners don't pick them up. Well, this gives us a chance to go out there and plot those points manually to make sure we got that evidence. No guesswork involved. So that was test number 1. Now our person that I chopped out of RealWorks just a couple minutes ago came from test 3. So what I'm going to do here is I'm going to make that active, and I'm going to import a point cloud. And here is our person that was walking. And since everything is all locked together, it's a little hard to see, so we'll bump up our point size just a bit. And we've now added our person in. And handy when you've got a ton of stuff at a scene, you've got EMS walking around, you've got all kinds of stuff here that you need to get rid of, or you need to bring in, chop it out, and then bring it in. So bringing in UAV data, I've already done it once, but I'm going to go through it again. I'll just create a layer called UAV, and I'm going to import the ortho photo. So this will be the top-down 2D ortho that was exported out of Pix4D. And I've got it here as the MATAI 2020 Transparent Mosaic Group. I'll hit open. Now because it's coming out of Pix4D and it was geo-referenced, we can set our image coordinates is equal to scene coordinates, hit start import. It'll take her just a minute here. All right, and we are complete. I'm going to take no action on this and just leave it where it's at. All right, and looking at it from top down, I'm just going to turn off my point clouds. And we now have our 2D ortho image along with our GNSS points for our area of impact, our hat, our shoe, and our car's final rest. That's fine for a flat 2D, however, let's bring in the point cloud as well. So I'm just going to do it in my UAV layer. I'm going to import a point cloud that is an LAS. I'm going to go find it here. Fix output. And I just got this morning around, what was that, about 8:30 when I got it, and I didn't have time to mess with it or do anything with it aside from bring it in. We're good. So we have about 6.8 million points here, and now we have our Pix4D point cloud loaded in. And this was a holdover from the X7 laser scans, so that's in there. We're set to go. And from here, knock out a quick diagram and get it out. Get the analysis done and let's move on. that's all I have for you guys. I just wanted to show you what your data looked like and how it all came together, because we had UAV, we had GNSS, we had laser scan, we had just a little bit of everything. About the only thing we didn't have was an optical total station thrown in or anything else. I mean, we used just about every mapping technology besides an optical total station. That's about the only thing missing from this, but that could have been done as easily as well. We could have brought out an S5 or fired up the SX10 and done the same thing. The nice thing that I like about Reveal and just the software suite in general is that it is data agnostic. It doesn't care what you're bringing in. If you generate it, you got your instrument, let's bring it in. Because we shouldn't have to be locked down into something that I can only bring in this because I bought this software. You should be able to bring it in. That's everything I have for you guys. Again, I just wanted to show you the data. Again, I haven't cleaned it. I haven't done anything. I chopped out some stuff and brought it in. This is raw. I haven't had a chance to do anything with it. Any questions from you guys? It got real quiet and I'm getting nervous. Wow, nothing.
You can create like wire diagrams and stuff too in the Pix40.
What kind?
Like a wire diagram, like you can actually draw your lines, poly lines, and points and stuff.
That is a very good question for our Pix40 expert.
Are you saying in here or in Pix40?
In Pix40, you can export those.
Can you export them as like a DXF?
Yeah. Out of
Yep.
Pix40, yes, you can draw your polylines and everything in Pix40, and then export it as a DXF, DWG, or
Yep.
right into
Absolutely. So let's see if I can. Here we go. So you can do an open DXF DWG. Nope, didn't want to do that. But yeah, you can bring in a DXF or DWG. Yeah, you can bring her in. So if you draw it, bring it in first, and then start adding stuff to it. It's about the easiest way to go, since that's what your framework is, or that's your line work, that's your framework. Bring it in, open it, and then just start adding stuff to it.
this software. Is it Trimble?
Yep, so this is Trimble Forensics Reveal, and this is a Trimble software.
Do you have any examples you can show me with that R4 how you took a picture? Data collection?
Yeah.
So I think there are some pictures attached of the body to some of the R4 data.
Yeah, let me get that back open here.
To be clear, I mean, this is just a point cloud. You can now draw a scene with this point cloud. So you can surface this. You can draw all the skid marks in. You can actually bring models of cars in. So instead of walking around your scene with this whole station to map that road, you can walk in your CAD environment now on your point cloud and map the road.
And I did do just a real quick surfacing here. I can very easily place a model in.
There's that one attachment.
Yeah, my layer management is going to get all kinds of ugly here. ST, we'll just throw in a Tahoe because, well, why not? All right, what I'm going to do here, I'm going to do this in top-down. I like working in top-down most of the time. All right, so there's our area of impact. I'll rotate my Tahoe around. Now I've got my vehicle right in front of the area of impact. I put an avatar in here and I'm set. So you were talking about the photographs. So here is one, this attachment. Get zoomed out here. So this attachment was taken by the TDC 600, or the R4 instrument was attached to it as well. As you can see, that was taken right from the pole. And it was attached to that point. which is, let me see if I can get down in there. Yeah, turn my ditch off. There we go. So it was attached to the foot part of that pointer, the foot of the avatar. From here, we can just convert this real quick. We'll convert it to an evidence marker. Say this is where the body came to rest. I'll put it in my evidence marker layer and hit OK. It now creates a little evidence marker tent for me. Now if I want to, I can go up to my reports and I can export an evidence report. And that now has all my photographs that I took as long as they were attached there. I can do it that way, or later on, I could take my photographs from my DSLR and add those in there as well. Good question on the photographs and attachments and that kind of stuff. Good question. Anything else?
We're gonna take from Tony's class, so.
Yeah. Tony, good to hand her back over to you.
We can process a little more, but we can put all this, we took a lot of videos, a lot of still pictures, and we can put it on a thumb drive and I'll do the class tomorrow. Okay, if you wanted to add